Today let's go over an easy question in the premium section that I just solved by myself. This one I actually struggled with quite a bit before. I looked at it a couple times, but today I was finally able to come up with something. I think I noticed a detail in the question, so let's go over it. So you're given an array of integers and the values are an arithmetic progression, so they're either all increasing or all decreasing. That's great. And you want to find a particular value where the difference is not the same as between the other values. And the key here that I missed originally was that the value cannot be the first or the last in the array. So how do we find out what the difference of 2 is here? Well, take the first minus the last minus the first, which is 8, and then divide by the length, that's 2. That's your difference. Here, for example, 15 minus 12 is 3. 3 divided by 3 is 1, so the difference is supposed to be 1. And this is sorted in ascending order, this is sorted in descending order, so that makes things a little easier. So once you know that, it becomes straightforward. So let's call this difference, which is going to be ARR of minus 1 minus, or the absolute difference of the max of ARR minus the min of ARR divided by the length of the array. So let's print the difference. Because here, for example, if you do 5 minus 13, that's minus 8, but we want positive 8, so we do the absolute difference. And here is just 5 minus 12 is 3, that's fine. So now that we have the difference, we can iterate over the array and find which one's the odd one out. So let's iterate from left to right. So we're going to go up to not including the last one because we want to compare the one in front with the current one. So let's call this length of ARR minus 1. Okay, usually you just don't have this, but now this is good. 11 is going to be the last element we check because we want to compare 11 with 13 and we don't want to go out of bounds. So now we can ask if the absolute difference of ARRI minus ARRI plus 1, because plus 1 is like 7 here, we're currently on 5. If this is not equal to the difference, then we know we have an answer. Okay, so we have to take care of both cases now, so we can print ARR of I and ARR of I plus 1 now. So 7 and 11 is the bad one out. So now if we have two conditions, right? If the current one is smaller than the next one, then we know we have to add to the current one, right? If the current one is bigger than the one to the right, right, we're currently on 15, then we know we have to subtract because this is a descending array while the latter was an ascending array. So in that case, we have to ask if ARRI, which is 7, is less than ARRI plus 1, then what do? We return ARRI plus the difference because difference was a positive number because of the absolute value we did. In any other case, right, return ARR of I minus the difference. And then at the end, if we never find something that's broken, like all the differences are the same, for example, if we had 5, 7, 9, 11, 13, then we just return 0 at the end. And there's one edge case here, which is that if there is no, so the difference here is actually supposed to be, it looks like 1, because if everything is the same, then we just return whatever the first number is. Because right here it says we want to return the removed value. So I guess in this case, the implication is that if there are no duplicates, if there are only duplicates, then we just return the first element, right? And it's a bit of an edge case there. You have to kind of play around with the test cases to see it, but other than that, it's not too difficult. So I hope this video was helpful and consider subscribing and stay tuned for more.